So this is quite a huge number, as you can imagine. And according to estimates, the maximum share these companies can get per new entrant is about 65,000 tons of CO2 equivalent. And this would be equivalent to, for example, 16 metric tons of 404A or of 45 metric tons of 134A. So this shows on the one hand side that you will not only have 5 or 6 big refrigerant producers who will be holding quota, but a lot of other companies who will also be holding quota, but it also shows that there is a big interest for this reserve which has been left, and that those who have applied for this reserve will get a comparatively small share. Who can apply for such quota? That's a very important point as well. Only those companies who are dealing with bulk HFCs can apply for quota. So the producers of these HFCs or the importers of these HFCs. Bulk means that the HFCs are not contained in equipment, but in cylinders, for example, in containers, in ISO tanks, etc. Manufacturers of pre-charged equipment, or for example, air conditioning manufacturers or heat pump manufacturers, etc., they cannot apply for such quota. And also the importers of such pre-charged equipment in the European Union cannot apply for quota. So that's the big pillar of the phase down. Then we have another big pillar, as I said already, which is the GWP restrictions in the new regulation. And this equates basically to bans of certain refrigerants when they have a high GWP. We have a first key target, which really is the main focus is on this one to start with, which are refrigeration applications. We'll have a ban from 2015 onwards of HFCs above a GWP of 150 in domestic refrigeration. And then the big key date, which will really be very important for the industry, is 2020, where HFCs with a GWP above 2,500 will be banned. So HFCs, which we've been using very often in refrigeration applications like 404A or 507, cannot be used anymore in new equipment from 2020 onwards. So that's fairly soon, and it's very important that the industry acts on this. There are certain exceptions to it, but really this is one of the key steps of these GWP limits. We also have what we call a service ban, which also enters into force in 2020, which means basically that not only these refrigerants will be banned for new equipment, but it will also not be possible to use them for service and for maintenance. So what does that mean? It means, de facto, it means a ban from now on, more or less, because afterwards you will not be able anymore to service your equipment with these gases. And from 2022 onwards, we will also have a ban of HFCs in hermetically sealed refrigerators and freezers for commercial use, and also in large commercial refrigeration equipment, as you can find it, for example, in big supermarkets, etc., with some exceptions again. There are also GWP restrictions on air conditioning and heat pump equipment. From 2020 onwards in movable room air conditioners, and 2025 onwards, and that's another big step here again, of HFCs with a GWP above 750 in small split air conditioning systems if they have a charge which is below 3 kilo of refrigerant. There are more challenges. As I said already, this whole regulation is geared towards promoting the use of lower GWP refrigerants. This is done by the phase down, by the GWP restrictions, but also by converting of what we had previously. Previously, we had to do leak checks and install leak detection equipment, etc., and this was based on thresholds in kilograms, expressed in kilograms. Now these thresholds are expressed in CO2 equivalent. So that means that for that equipment where previously you may not have needed to use a leak detection equipment or to carry out leak checks, now needs to be done so because the threshold is expressed in CO2 equivalent and not in kilo anymore. So to take a concrete example, beforehand, if you had an installation with 3 kilograms of refrigerant charge, this installation did not need to be leak checked. But now, if you have 3 kilo of 404A in that installation, it'll be suddenly above the threshold because the threshold is now expressed as CO2 equivalent 5 tons, so you will be above. So that again is another incentive, another push towards using low GWP refrigerants, because then you may have less leak checks and less requirements in terms of leak detection equipment. So to conclude, it's really very important that the entire supply chain adapts to these new rules. And this is not something which can be done from 1 second to the other. It's nothing which is easy to be done, but it's feasible. It's a big challenge, but it's also a big opportunity for our sector. The producers of refrigerants have already started quite a while ago by developing lower global warming potential refrigerants to support and to enable the phase down. We can see that there are a lot of alternatives which are already around. We can also see that a lot of new blends are being developed. So there will be quite some choice for the market to be used. We can also see that these new refrigerants very often are flammable. We can see that there is high pressure, there are toxicity requirements, so it'll require adaptation of the market. What we can also see already now is that equipment manufacturers have already started adapting to the new rules and are continuing to do so. They are switching to lower GWP refrigerants wherever it is possible. But we can also see that more investments into R&D are necessary to be able to develop safe and energy efficient and also economically affordable products. Some sectors, as we could also see, can move more quickly than others, and that's not just linked to the technology, it's also linked, for example, to the climate, and I don't think I need to say this here. But we can also see in Europe differences between North and Southern Europe, for example. And we can also see that early action pays off because the higher GWP HFCs will be the first ones who are impacted by the phase down, and of course we can expect price increases, etc. Another big change and adaptation will be required by the installers. They need to get trained for the use of flammable products, and that's going to be a very big step because it's about the safety of all of us. And they need to be trained to handle high pressure and also toxic refrigerants. And of course, the end users have a big responsibility as well. Besides the appropriate leak checking, they need to make sure that working conditions are fine, that equipment can be handled safely, etc. So we can see a short, a medium, and a long-term impact. And the short-term impact is really, and I can only repeat this again and again, is that the high GWP HFCs such as 404A and 507 will need to go and will go first. They will need to go first because otherwise they take up too much of the CO2 equivalents within the phase down, and they will actually take away CO2 equivalents from other applications where we may need them still. But also because we have the GWP restrictions in place here. So these refrigerants will go, and they will go fast. By going, they will be replaced, I guess, in several steps. We will see the uptake of medium global warming potential refrigerants, like, for example, a 407F, 407A, etc. We will also see a move towards much lower GWP refrigerants wherever possible. We see already a lot of CO2 in commercial refrigeration applications, for example, and we will see the HFOs being more and more used. We'll see R32, for example, being used. So we'll see a move towards medium and very low GWP refrigerants also in the very short term wherever it is possible. And of course, the stricter leak checking requirements, as I mentioned already. In the medium and in the long term, I think the key step for our industry sector is to develop a better understanding for the use of mildly flammable and flammable refrigerants. This is really key for the future of our industry and also for the safe future of our industry and of the users. Manufacturers will have to work on the safety precautions, will have to train the installers. The standards need to be developed that reflect these new challenges, and of course also all the local and national building codes which we have in Europe need to be adapted accordingly. So finally, as I said already, the phase down is really the major new pillar for our industry, for our sector, for the users, and it will push everybody towards lower GWP refrigerants. The GWP limits, which I explained, will set signposts to steer this phase down, to wake up, to shake up the people in the industry. All HFC refrigerants, and that's another very important factor which is very often misunderstood, but really all of the HFC refrigerants will be impacted by the new rules. It's not only the high GWP HFCs, all of them will be impacted. There will only be a stronger impact on the high GWP than on the low GWP, but all of them fall under the phase down. The higher the higher the GWP, the higher the impact, of course. So the industry really needs to act now to avoid shortages. The market needs to adapt to flammable refrigerants. Education and training of the entire supply chain is key, and we have to make these rules work. And that's also a priority for us as an association. And that's my last slide. I would just like to underline how serious as EPE, as an industry association, we are about these new rules. We have published this pledge within the framework of the New York Climate Summit and the Climate and Clean Air Coalition, that we really want to make sure and are committed to making these rules work and understood across all sectors, to cooperate with other associations to make sure this is really happening, both at the EU and at an international level. We'll develop, and have already started to do so, appropriate communication materials, and we will also tackle barriers which we can still see. We'll have within our association a low emissions task force. We'll track the effectiveness and the efficiency of the new rules, and also raise awareness on an international level, which is why I am here. And that's it. I hope I stick to the time, more or less. So thank you very much for your attention, and happy to answer your questions.
Thank you very much, Andrea, for this very operational introduction to the F-gas regulation in Europe. You were 2.5 minutes late, but we didn't want to disturb you. We may think of awarding the presentation that comes closest to the 15 minutes by the end of tomorrow. But let's see. I will quickly jump into the next presentation, which deals with the same subject, and I'm happy that we have with us Arno Kassel from the European Commission. Arno studied biology, and he's specialized in contaminated soil. In 2004, he joined the European Commission, and he's now working for the DG Climate, and he's involved in developing and implementation of policies on fluorinated gases. So you can imagine Arno has a big fingerprint, or maybe even a footprint, on the F-gas regulation. And I'm happy to invite you here to elaborate on EU efforts to reduce direct HFC emissions. Please, Arno, the floor is yours.
Assalamu alaikum, Sabah al-Khair, and shukran to the organizers, to the introduction. I'm quite overwhelmed by the amount of people we have here today, so that's excellent. And it shows, of course, the importance of this issue to the region and to the industry. I'm very grateful to Andrea to making this excellent presentation. I felt introducing already the details of the phase down and our regulation, because it's not, it's a little bit of a tricky issue to explain, and she did that very well, and I can confirm that all the numbers that she quoted are fully correct. So that leaves it for me a little bit to frame the new legislation, the new EU phase down, and maybe talk a little bit about the impact also beyond the borders of Europe. So, okay, this would have been my first slide. Let's move straight on. As said in the introduction, I have a bit of a research background, so I like data. So that's why I'm starting off with this slide. You see on the left side of the slide, you see the consumption of ozone-depleting substances in the EU. And you can see that until 2009, we still had a positive consumption at a low level. From then on, it's negative in metric tons. So we have completely moved out of the ozone-depleting substances. You see on the right side of the slide, you see the effect this has had on emissions of other substances, namely here the HFCs. You see a continuous rise, and if we take out the HFC 23, which is byproduction from industry, it is even more clear that from the 90s, from zero basically, it went up to 100 million CO2 equivalents today. And that's of course because we phased these high GWP HFCs in while replacing the ODS. On the left side of this slide, you can see the net supply of HFCs, meaning those, it's similar to consumption, the figure. It's not quite the same, but what is used in the EU today, and the green, let's see if the laser works, wonderful. The green is the HFCs, and then we have other fluorinated gases here. You see, we had a bit of a peak in 2010. Since then, we have a small decline every year in the HFCs we use, but of course, this is not enough to break the trend and reduce HFC emissions as we want to do. You also can see, if we look at the sectors that use HFCs, you can see that the refrigeration air conditioning sector is the most relevant sector, and that's will of course bear the brunt of our new measures also. Just to remind you that we've had legislation on fluorinated gases, including HFC, from 2006. It focused more on the refrigerant management measures, such as keeping the equipment leak-tight, training personnel, keeping records and reporting. But we've also had, since 2006, the MAC directive in place, which addresses the important sector of air conditioning in cars, where there's this, in 2011, we had a date of new types of cars that would have had to use refrigerant lower than 150, and from 2017, it's for all new cars. So that's quite important already from the past, and this is now coming to today's, and you have seen a similar picture from Andrea of the face-down steps, so I can be relatively short here. Why did we target fluorinated gases ourselves? Well, it's part of the larger package of doing measures on climate change, and we've identified that in this sector we have a sufficient number of alternatives available that make it very cost-effective to do efficient mitigative action and save a number of important emissions. Member states can, to a degree, go even further. They are also able to, under the Kyoto obligation that we have as the EU, can make measures on HFCs count towards these on fluorinated gases. So this to show you a little bit what we can achieve. You see in the upper graph where we would have been in a business as usual on fluorinated gases. We would have doubled from today's levels of 120 to 200. With the new regulation, we can go down to 40 million more or less in the long run, so it's quite a large savings, amounting to 1.5 gigatons by 2030 and 5 gigatons by 2050. Just to show you a little bit how this compares to proposals under the Montreal Protocol for an HFC phase-down, we constructed our phase-down so we would be able to meet until 2030 these proposals as they are on the table. You see that in the long run, we do not, but our proposal was constructed until 2030. So you see this is the EU phase-down that is in our legislation. We can meet both proposals that have been made. So again, moving a little bit on to how we may impact beyond the world. We, of course, drive innovation, drive technology to move further. Andrea mentioned this quite well already. This is, of course, impacts on other regions of the world because these alternatives will also become more readily available and less costly for them. So we are really looking towards others to work together and see how we can together maybe move forward also at a global level, because of course at the global level we can get much more than these 5 gigatons that I mentioned that we can save in the EU alone. We also think that now is the right time to act because, as you know, Article 5 countries are only starting to phase in HFC, so if we make the right decisions there, we can already avoid a lot of problems for the future. When we move to the technical discussions over these 2 days, it will be important to look at different sectors, because of course every single sector and subsector has different alternatives available, and the situation is different. So we cannot go overall and discuss about high ambient temperature. We really have to identify sector for sector, and you have here some of the subsectors of refrigeration and air conditioning separated, and we would have to look singly, at least that's my proposal that we do, what alternatives we have available and where problems are, what these problems are, and how they might be solved. Another issue is, of course, that not all sectors are equally important. What you see in the pie chart here is that some sectors use more HFCs than others because, of course, they sell more equipment in the sectors. They're more relevant from an HFC point of view, and that also translating also, of course, in the end into more emissions, usually. You see in the pie chart, the more reddish ones is more the air conditioning. This is an overall for Article 5 countries. In this region, of course, air conditioning is one of the major sectors that we need to be looking at. Now, this is quite a slide that has quite a lot of information. It is from one of our consultants, their view on suitability under high temperatures, spelled out if we look at different subsectors and what alternatives are available. As I said, it has quite a lot of information. You have here the low GWP alternatives that are available. High GWP we did not put in the table. 4,4A and 410A are probably not the best solutions for the high ambient temperatures anyway. CO2 is not included because it usually suffers under very high temperatures from an energy efficiency problem. Possibly within cascades, it can be used if it's not exposed to the ambient temperature, but this is disregarded in the table. So if we, oh, sorry, that was too quick. Let's see, okay. If we move into different alternatives available, you see hydrocarbons are generally under